one ready. All right, let's jump right in. Today, we are pulling back the curtain on the secret language that powers literally everything you do online. We're talking every game you play, every app you use, and even the stuff that keeps your digital world safe. We are talking about algorithms. So, let's start with a really big fundamental question. How do you actually give instructions to a computer? I mean, you can't just tell it, hey, build me a cool game. It doesn't work that way. It needs a plan, a super specific recipe. And getting that recipe just right, well, that's everything. Because here's the catch. Computers are amazingly fast, but they don't think for themselves. Not even a little. They follow your instructions, exactly, literally, with zero imagination. So imagine you told a computer to make a peanut butter and jelly sandwich, but your instructions were kind of vague. You'd get a total mess, right? Like the knife's still in the jar, peanut butter on the ceiling, you get the idea. Precision is absolutely everything. So to write those perfect instructions, you're going to need the right tools. Think of it like you're gearing up for a big mission. Today, we're adding two really important items to your coding toolkit that are going to help you plan and build like a total pro. First up, the algorithm. Now, I know it sounds like a super complicated technical word, but honestly, it's just a fancy name for a step-by-step recipe that solves a problem. Seriously, whether you're following instructions to bake a cake or coding a video game, you're using an algorithm. It's your core logic. It's your plan of attack. Okay, so how do we actually write down that plan of attack before we start typing out a bunch of complicated code? Well, that's where our second tool comes in, pseudocode. It's not a real programming language. Nope, it's just you planning out your algorithm in plain English. Think of it as the bridge between your awesome idea and the final code. Let me put it this way. Imagine you're an architect. You wouldn't just show up to a construction site with a pile of bricks and hope for the best, would you? Of course not. You'd have a detailed blueprint. And that's exactly what pseudocode is. It's the blueprint for your game, letting you map everything out and spot problems before they happen. And when you use these tools, you're basically leveling up two massive skills. The first one is reflectiveness, which is all about planning and thinking through your steps logically. And the second one is decomposition. This one is like a superpower. It's the ability to look at a huge, scary problem and just chop it up into smaller, bite-sized chunks that you can actually solve. All right, toolkit is packed. Skills are ready to activate. It is time for today's main event. Welcome, agents, to Operation Clovercatch. Your objective, should you choose to accept it, is to build a fun little arcade game from scratch. You're going to code a game where you control a bunny, and you've got to zip around the screen grabbing all the clovers you can, all while dodging some very angry bees. And this is where that decomposition skill kicks in. Instead of trying to build a whole game at once, we break it down. See? We've got player movement, that's one piece. Making clovers and bees pop up on the screen, that's another. Figuring out when things touch each other, that's collision detection. Then we need scoring. And of course, we need to track our lives. Each one is its own mini problem to solve. And boom, this right here is our game plan. This is the pseudocode, our blueprint for Clovercatch. Look how logical it is. First, you set everything up. Then you have a rule for spawning new items. Then you have your action rules for what happens when the player touches a clover or a bee. And finally, the end condition. See how it just flows from one step to the next? But hold on a minute. This isn't just about making a fun little game. Oh no. This is where things get really interesting. Because there's a twist. Every single part of this game you're about to code has a hidden connection to something way more serious, cybersecurity. So, check this out. Those clovers you're trying to collect, think of those as safe things you do online, like setting a strong password. And the bees, well, those are the threats, like a phishing email or a virus. So every time you collect a clover, that's like you successfully blocking a threat. And every time you get hit by a bee, that's a successful cyber attack. And your lives? That's basically your system's overall security level. So here is the really crucial takeaway. You're not just coding a game today. You are literally building a small-scale model of how digital defense works. The algorithm you write, that step-by-step plan, it's not just game rules. It's a defense plan. Which brings us to the big question I want you to keep in the back of your mind as you're working today. How does your game plan, that pseudocode you're about to write, actually become a defense plan? How does the logic of the game translate to the logic of protecting something online? Think about that. Okay, let's wrap this briefing up. We need to be absolutely crystal clear on your mission objectives. This is what success is going to look like by the end of this. So it's pretty simple. On the left, we've got our learning intentions. This is our goal. We want you to really get what an algorithm is, use that knowledge to write some pseudocode, and start seeing that cool connection to cybersecurity. And on the right, that's the success criteria. That's how you'll know you've completely nailed it. You'll be able to define an algorithm, write out the plan for CloverCatch, and explain exactly how grabbing a clover is like stopping a cyber threat. Your briefing is complete. You have your tools, you have your mission, you have your objectives. So, mission accepted. Let's get coding.